Welcome to a deep dive into revolutionizing incident management. For any software engineer or IT professional, the dreaded pager alert in the middle of the night, or a frantic war room session trying to debug a production issue, is an all too familiar nightmare. In today's complex distributed systems, especially with vast Java workloads generating mountains of logs and metrics, manually sifting through data to detect, explain, and resolve incidents is not just time-consuming, it's error-prone and frankly, exhausting. But what if we could automate a significant portion of this operational burden? Imagine if an intelligent assistant could analyze your real-time data, pinpoint issues, explain their root cause in plain language, and even suggest concrete resolution steps. That's precisely the future generative AI is bringing to incident management. This project demonstrates a practical application, turning raw data into actionable insights. At its core, GenAI for smart incident management transforms the chaotic stream of application logs and metrics into structured, actionable intelligence. Instead of just alerting you to an error, it functions as an intelligent assistant, providing context and guidance. Think of it. A log entry that previously meant digging through dashboards and tracing code now becomes an instant incident report. This solution leverages the power of large language models, or LLMs, to process natural language within your log messages, identify patterns, and generate human-readable summaries that go far beyond what traditional monitoring tools can offer. It's about understanding the why and the how to fix in real time. This intelligent system is built upon three core concepts that are vital for effective incident response. First, incident detection. It automatically identifies potential incidents or anomalous patterns from the continuous streams of log data and metrics your Java applications generate. This goes beyond simple keyword matching, aiming for nuanced anomaly detection. Second, contextual explanation. Once an incident is detected, the GenAI doesn't just flag it, it provides a human-readable explanation of what the incident is, why it occurred, and its potential impact on your system. This level of insight helps engineers quickly grasp the situation without extensive manual investigation. Finally, guided resolution. Perhaps the most powerful aspect is its ability to suggest concrete, step-by-step actions or remediation strategies to resolve the detected incident, potentially drawing from historical knowledge bases or best practices. To demonstrate this revolutionary approach, we've built a proof of concept using a Spring Boot application. This setup simulates the crucial interaction with a GenAI model, showcasing the architecture without requiring complex external LLM deployments for the demo itself. Here's how it works. First, a REST API endpoint is responsible for log ingestion, receiving application log entries or simulated metrics. This acts as the data pipeline from your Java applications. Next, a GenAI service, within our application, invokes a simulated GenAI model. In a real-world scenario, this would involve direct API calls to powerful LLMs like OpenAI's GPT, Google's Gemini, or Anthropic's Claude, or even a fine-tuned custom model tailored to your specific environment. Finally, this service processes the log data and returns an elaborate incident report containing the detection status, a detailed explanation, and precise resolution steps. This report is then returned via the API, ready to integrate with your existing alert systems, dashboards, or ticketing tools, closing the loop on incident response. For the purposes of this demonstration, the GenAI model's behavior is cleverly simulated within our Java application's service layer. Instead of requiring actual API keys and incurring costs for external LLM calls, it uses predefined patterns and logical rules. For example, it might search for keywords like out-of-memory error, null pointer exception, or timeout within incoming log messages. Based on these matches, it generates plausible and comprehensive incident reports. This simulation allows us to clearly illustrate the output and the immense utility of such a system. It lets us focus on the what and the why of smart incident management, rather than getting bogged down in the complexities of real-time LLM integration for a simple POC. It truly brings the concept to life. Let's consider a common and critical Java application issue, the out-of-memory error. Imagine your application logs suddenly show entries like java.lang.outofmemory error, Java heap space. Traditionally, this means frantic checking of metrics, thread dumps, and heap dumps. With our GenAI-powered system, when such a log message is ingested, the simulated GenAI immediately flags it. The generated incident report would state is incident, true, type, memory leak/exhaustion, with a clear description, application is experiencing out-of-memory error, likely due to heap exhaustion. The explanation would delve into the typical causes, memory leaks, excessive object creation, or an undersized heap. Crucially, it then provides actionable resolution steps. 1. Analyze heap dump to identify memory leaks. 2. Increase JVM heap size. 3. Review recent code changes. 4. Check for unclosed resources. This is a game changer for incident response. Another frequent culprit in Java applications is the null pointer exception. This infamous error often signifies a logical flaw in the code. When our GenAI system processes a log message containing null pointer exception at com.example.myClass.someMethod, it springs into action. The resulting incident report would accurately identify the type as application error, null pointer, and provide a description like application encountered a null pointer exception, indicating a programming error. The explanation goes deeper. Null pointer exception occurs when an application attempts to use an object reference that has not been initialized, i.e., it's null. This is a common runtime error in Java and usually points to a logical flaw in the code. The recommended resolution steps are equally precise. 1. Identify the exact line of code from the stack trace. 2. Debug the code. 3. Add null checks where necessary. 4. Deploy a fix and monitor for recurrence. This level of detail empowers even junior engineers to tackle complex issues. External dependencies are often Achilles' heels for distributed systems. A timeout or connection refused error indicates a problem outside your immediate application. When a log entry like database connection timed out or service X connection refused is fed into our system, the GenAI model immediately categorizes it. The report would highlight type, external service/network issue and describe it as application is experiencing connectivity or timeout issues with an external dependency. The explanation clarifies, timeouts or connection refused errors often indicate problems communicating with external services, databases, APIs, message queues, or underlying network infrastructure issues. And the resolution steps guide you through the diagnosis. 1. Verify the status of the external service. 2. Check network connectivity. 3. Review firewall rules. 4. Examine application configuration. 5. Consider implementing retry mechanisms. This proactive, guided approach significantly reduces mean time to resolution. The real power of this GenAI approach lies in its ability to provide contextual explanations and guided resolution steps. Traditional monitoring might show you an error count spike or a high latency alert. But it rarely tells you why that's happening or how to fix it. GenAI bridges this gap. Instead of just error, database connection failed, you get **** type **** database connectivity issue. Explanation ** The application failed to establish a connection to the database, potentially due to incorrect credentials, network partitioning, or the database service being unavailable. Resolution steps **